Thanks, everybody. Always great being here at CloudFest with so many amazing partners. Before I jump into all of the amazing innovation that's occurring today in the cloud, I actually want to take a step back and start a little bit at the beginning. So if we go back a couple of decades and we look at the type of infrastructure that people were building, we had a world where you were running one single monolithic application on one single server. And so as you can imagine, that was pretty inefficient. So how many people here today still run their entire infrastructure that way? Single app, single server, low utilization. OK, so I don't see that many hands. So I think hopefully we're all in the right place. So things luckily evolved past that. So we saw the introduction of virtualization. And so once virtualization was introduced, then we were able to run multiple applications on the same server, each with their own OS, and also each with their own resources. And so once that happened, utilization improved, efficiency gains were had. After that, we started to see on-demand virtual machines available. And so once that happened, now all of a sudden, you started to see things like self-service, automation, multi-tenancy. These became standard for the cloud. As things evolved further, we actually started to see the entire data center, in some cases, be considered one monolithic computer. And we were able to do that because control began to happen at the process level because of technologies like containers, as well as innovations like advanced schedulers, advanced orchestrators, tools like Mesos and Kubernetes. And so at this point now, we see this type of cloud infrastructure, one version of this, pretty much everywhere. Whether we're talking about traditional enterprises that are hosted in public cloud, whether we're talking about private clouds that are owned directly by companies themselves, or whether we're talking about companies that are born on or born in the cloud. And we've been talking about this paradigm now for almost 2 decades. And we'll continue to talk about this type of architecture for some time. So all this innovation is really impressive. But the thing that's actually really fueling the growth in the cloud is the growth of the underlying services that rely on this infrastructure. Traditional IT has been growing at around single-digit growth for many years. On the other hand, our cloud service provider growth has been in the double-digit range for over a decade. And so this explosive growth comes from where we're able to marry the amazing innovation at the technology layer with the amazing services that are growing your businesses today. So it's not just from the efficiency gains in the technology alone. If we look at the major growth areas, one major one is digital retail. Over the next 2 years, digital retail will grow to be a $4.9 trillion market. And that might sound like a lot, but today, even only 18% of all transactions in the retail space are actually done online. So there's still a lot of room for growth here in the digital retail space. Another major growth area is digital advertising. So as consumption of news and of media increases, we see a corresponding growth in digital advertising. And then lastly, there's large growth in digital video and media. So as additional usages like AR, VR, 360-degree video, as these become common, those are also fueling the growth in the cloud. And so together, those things fuel the large growth in cloud services that we see. And as you're looking at what you need to do from a cloud services perspective, think about the businesses that are going to grow on top of it, how your infrastructure is going to be consumed. Is it going to be consumed as an infrastructure offering? Is it a platform offering? Are you going to be offering up functions to help software developers fundamentally rewrite the way that they think about code? So all of these explosive cloud services, these are the catalysts for business transformation. And the consumption of those will then fuel the growth in your businesses. However, there are some roadblocks here. So 71% of CIOs recently surveyed indicated that legacy infrastructure is actually a barrier to their ability to innovate. And that might explain why we've seen single-digit growth in traditional IT over the last decade, versus double-digit growth in the cloud service provider space. So it's important that these types of business initiatives align with the underlying technology that's needed. And so we find that when you're able to deliver the right infrastructure, as people move to public cloud, their consumption of resources of your platform end up growing. At times we see as much of a 2 to 10x increase in the services consumed as someone moves to a more innovative cloud model. So it's not just about efficiency, it's also about ensuring that the cloud technology is also delivering the right business scale, flexibility, and agility. And moving forward, we do expect to see large transitions of enterprise workloads to the cloud. So over the next couple of years, over 80% of all businesses will use the public cloud, with 41% of all their workloads running there. So as cloud service providers, or as providers of infrastructure, or as services owners, what are some of the key technology challenges that you face today? Now, as we've worked with cloud service providers around the world, a couple of global trends have emerged from a technology standpoint. One, cloud service providers are looking to scale up cores, looking to deliver higher performing, more cores at lower cost from a TCO perspective. They're looking to scale up I/O for lower latency, higher IOPS, looking for maximum memory and storage bandwidth and capacity in order to ensure low latency. They're looking to increase VM density at the rack level and also improve virtual machine concurrency. And the key to all of this is that this allows them to deliver the maximum possible performance per TCO dollar at the rack level for the specific workloads that they or their end users actually care about. So all of this helps you maximize your investment in the infrastructure. So these are some of the key considerations that we've taken into account as we've built our strategy at Intel as your technology partner for the future. So as you look for your cloud business to move into hyperscale and continue to grow, you need to consider what's the strength of your technology's performance for your customers' business agility. Do you offer the right flexibility to your business partners? What's the speed at which you can scale your infrastructure for your end users' demands in order to help them innovate at the services level? So I'm going to show you today that Intel, we've been around working with cloud for several decades. We've been there since the start. We've been there since the first hardware-assisted cloud VM migration features were built in over 10 years ago. We've continued to explore, to innovate, deliver performance in the cloud since then. And I'm sure that we're going to be around for decades to come partnering with you as well. And that's one reason why I really love working at Intel. So you can see here the full breadth and scope of the Intel portfolio. And I'm not going to go into a long product pitch here, but the important thing is to understand that we're making investments in the key technology areas that are important for your platform. So of course, this all starts with the Xeon Scalable processors. We'll have some new ones launching here very soon. I'll talk a little bit more about what's coming with those. We also have our new Optane DC persistent memory. I'll talk a little bit more about the game-changing performance that that's going to enable. We also have our high-speed Ethernet, our Optane solid-state drives. We have our SmartNICs, our FPGAs. We have our silicon photonics that allows you to run high-speed interconnects at scale. We have IoT devices for AI and for function as a service. And I'm also going to talk a little bit about the solutions level today with our new high-density cloud-optimized platforms that we launched at OCP Summit 2 weeks ago. So you can see here, we're able to innovate across a broad spectrum of products across the portfolio. So there might be companies that offer great storage solutions out there. There's companies that offer great networking solutions. There's a handful of companies that offer great computing platforms as well. Intel, I believe, is the only company that's able to actually bring all of that together in one solution to help you innovate in the cloud. So we walked through the portfolio a little bit, but in terms of how this is going to fundamentally change the market and our mindset for what we need to deliver to the cloud, as we move from a world in which most of the data is being generated by humans to a world where most of the data is actually being generated by machines, we have to fundamentally change the way that we handle that data in order to be sure that it's actually effectively used. So we have a lot more data coming in from the edge. A lot of it's unstructured. And so today, only about 1% of all the data that's being generated is actually being stored, analyzed, acted upon. So there's a lot of data out there that's just not being used today. And so in order to solve some of those problems, reduce the bottlenecks, it's important that we deliver efficient ways to store more, to move faster, and to process everything. This is core to our strategy in delivering a data-centric portfolio to the cloud service provider market. I'm going to start off on the storage front. So hopefully you've actually heard about this by now. So our new Intel Optane DC persistent memory product, I've actually got one right here. So this is a fundamentally new technology that we're bringing to the marketplace. And the problem it solves is that today, storage is oftentimes too slow, and memory is oftentimes too small. And so there's a gap there in that memory and storage hierarchy. And so what we've done is we've taken a new technology, and we've created a new class of products that bridges that memory storage gap in the hierarchy. So what this allows us to do is deliver very, very high capacity memory. So the memory module that I'm holding in my hand right here, this is 512 gigabytes, so considerably larger than any existing DIMM that's available. And it's much more affordable. So this allows you to scale out to larger and larger memory capacities than you were able to previously. It's also persistent. So this is fundamentally different than DRAM. And this helps, for instance, in mission-critical applications where restart times are important. There'll be a number of different applications that take advantage of the persistence of this product. So fundamentally new class of products that's going to enable very, very high-speed storage, very, very large memory, and again, persistence in applications that value it. So specifically where we see this product being used, we obviously see great applications for it in the storage space, in the cloud and virtual machine space. So for instance, we were able to deliver 4x better VM density in Redis with this product. Also in the database space. So there's been a lot of talk about the way that our Intel Optane DC persistent memory can be used for in-memory databases like SAP HANA. In fact, back at Sapphire last year, Hasso Plattner named our Intel Optane DC persistent memory one of the best innovations of 2018. So SAP obviously sees the great value in this product. In fact, in tests with SAP HANA, using the Intel Optane DC persistent memory resulted in 12.5 times faster restart times for those very, very large databases like HANA. We also see great applications for this product in AI and analytics, HPC, in the comms space as well. Some specific examples. So with Apache Spark, one issue we see right now is that as the data sets that are being used for analytics get bigger and bigger, the ability to actually contain those in memory is restricted. And so that means that analytics times end up slowing down. That means slower time to results, slower time to the business results you're looking to achieve. So using the Intel Optane DC persistent memory with Apache Spark resulted in 8x higher system performance due to the larger memory footprint that was able to be enabled. Another example in the storage space is Cassandra. So very large distributed database. It shows up in a number of different applications. You probably use it today when you're downloading maps, when you're streaming movies, when you're chatting. And so with Cassandra, we were able to demonstrate 9x higher read IOPS with Intel Optane DC persistent memory. So fundamentally changing the performance of Cassandra. And then lastly, AeroSpike, another example from the in-memory database space. This is another one where traditionally memory has been too expensive, or DIMMs haven't been large enough to actually store the types of in-memory databases that users want to. This product fundamentally changes this by allowing at least a 3 terabyte per CPU socket memory capacity, so much larger than you're capable of delivering today with traditional technologies. And then also, again, on the restart time, so as more and more mission-critical and enterprise applications move to the cloud, having that downtime or having to interrupt services for maintenance becomes unacceptable. So with AeroSpike, we demonstrated 100x faster restart times because of the persistence of this product. So looking beyond the Intel Optane DC persistent memory, in the storage space, we're really focused on 3 areas. So enabling big, affordable memory, driving down the cost of bulk storage, and then also delivering efficiency at scale. So not only do we have the Intel Optane DC persistent memory, but we also have our Intel Optane SSDs. Those combined with software are actually available to extend your memory now. And in fact, the Intel Optane DC persistent memory that I mentioned, this is shipping today. We have customers that are actually using this right now, and this product is going to launch very, very soon. So driving down the cost of bulk storage, we're able to deliver very, very efficient warm storage solutions with our 3D NAND SSDs. We've also created innovative new TCO optimized form factors like our EDSFF, or what you may have heard referred to as the ruler form factor for SSDs. Also, using those Optane SSDs as cache, those are going to break through some of the system bottlenecks that exist today, and so that helps you to scale storage even more in a more efficient manner. So moving on to more of the networking space, I mentioned that we also need to be able to move data faster in order to break through some of those bottlenecks with moving data either from the edge into more centralized data centers or even just across the data center or within the rack. So we have a whole portfolio of products that are aimed at solving some of the bottlenecks there. Our goal here is to accelerate network traffic and enable companies and data centers to thrive in this new data-centric era, using products from our Intel Ethernet to our SmartNICs to our silicon photonics products. Our Intel Ethernet products, they provide connectivity plus advanced functionality for fast packet processing and network virtualization. They also build in other capabilities to accelerate network traffic. We have over 30 years of continuous innovation on our Ethernet products. So these are highly optimized to take network performance to the next level. And as we see network bandwidths increase to 25 gigabits and beyond, network and storage and the security functions, they really start to actually consume a lot of your compute cycles. So we've also now introduced our Intel SmartNICs. So those help you to complement the Intel Ethernet NICs. They provide additional levels of programmability, flexibility, functionality, scalability. Allows you to run functions such as virtual switching, storage, network security applications, and move some of that over from the cores, freeing them up to generate more revenue for you, and also creating that flexibility to grow over time. And then our silicon photonics products. So as we see east-west traffic increasing in the data center, it can become increasingly important to improve the bandwidth across the data center from rack to rack. So our silicon photonics products deliver 100 gigabit performance and beyond. And the key thing here is that we're able to take our core competencies in scaling our manufacturing process via Moore's Law. We're able to apply those same things to silicon photonics products as we're going to be able to deliver the lowest price per bandwidth over time to allow you to efficiency scale for your customers' needs. Okay, so we've got a collection of storage products, a collection of network products. I'll get to the compute stuff in a second. But I want to show you a little bit about how all of this actually comes together in one solution. So if we take a combination of our Intel Xeon Scalable processors, our high-speed Ethernet, and our NVMe-based PCIe SSDs, we're able to drive better user experiences with a more efficient infrastructure. As an example here, we've used Microsoft SQL and Exchange running on our Intel Xeon Scalable processors, our 25 gigabit Ethernet NICs, and then also we upgraded the Intel SSDs from SATA to NVMe-based PCIe drives. And by doing that at the full solution level, we're able to deliver 2.5 times greater VM density, 1.9x higher CPU utilization, and up to 2.8x more orders per minute to improve performance for the end user. So the metric that really matters to the business also improves as a result of the full stack of solutions. So it wouldn't be an Intel presentation if I didn't also move on to the processors. So we've got a number of key innovations coming out in this space. You're probably already familiar with our Intel Xeon Scalable processors that launched back in July of 2017. And we're on the verge of launching the next generation of those processors, codenamed Cascade Lake. These processors have a number of innovations. We're delivering additional performance enhancements. In the first generation of Intel Xeon Scalable processors, we really designed the architecture from the ground up to be relevant for not just a data center usage, but for a cloud usage by creating balance across the platform, across compute, across I/O, across memory. And we've furthered that with the next generation of Intel Scalable processors. So we're delivering higher frequency for higher performance. We've also optimized the cache hierarchy for the specific types of usages that you'd see in the cloud. And then we're also delivering some hardware-based mitigations for some of the security issues that we've been talking about last year, like Spectre and Meltdown. Also, this is the processor that supports the Intel Optane DC persistent memory that I showed you earlier. And then finally, we're innovating specifically in the AI space. So much of the AI work today actually occurs on the CPU. In fact, in the inference space, the vast majority of all deep learning inferencing is actually occurring on the CPU. That's important because inferencing often happens at the edge. It happens across your entire environment. You don't typically have a dedicated cluster just for inference. So we're introducing new features, starting with VNNI, or our Intel DL Boost technology. What this does, it allows you to improve inference performance by combining multiple instructions that previously had to be executed on different cycles. And this allows us to improve inference performance by 11x compared to the performance that we saw on ResNet 50 running Café back at the time that we launched the Intel Xeon Scalable processor in July of 2017. And we'll continue to deliver additional improvements, specifically in the artificial intelligence space, as we look out to our next CPUs beyond Cascade Lake. One thing worth noting is that while we're building in all these amazing features into our CPU, we need to also keep in mind all of the enablement work that goes on to ensure that your users are actually able to take advantage of them. This is an actual example of work that we did with Amazon on EC2. Previously, if a user went on to EC2 and selected a CPU-based offering in order to run deep learning, they actually needed to go back, they needed to rebuild their framework from source in order to take advantage of all of the features. We worked with Amazon to do all the work from, one, ensuring that they actually were using the right infrastructure with AVX 512. These are the instructions that help to accelerate artificial intelligence. In the future, we'll do the same work around DL Boost, ensuring that the kernel is on the current rev that supports these features, ensuring that the hypervisor is NUMA aware, having all the runtime libraries loaded like MKL, DNN. and then using all the Intel optimizations that we've delivered to TensorFlow. In the case of AWS, they also utilize Kubernetes with Kubeflow. And so by doing all of this work, they were able to increase performance by 7.4x. And now there's actually a pre-configured AMI available on AWS. Now, this might seem like a lot of work, but the good news is, at Intel, we've done this work. We've made it simple to go and ensure that you've got the right configurations to take advantage of the product. So it's important to understand all the ecosystem work that goes into delivering these types of solutions. It goes beyond just the core product. And so speaking of work that we've done innovating across the cloud service provider space, I'd like to bring on stage one of our key partners from 1&1, Reiner Strayer. He's the head of global platform hosting, and he's going to talk a little bit about some of the amazing innovations that they are working on in the web hosting space. Thank you.
Thank you, Jeff. Good morning. Jeff asked me to give you some insight in one of our hyperscaling cloud platforms. And I selected a web hosting platform. Why web hosting? Some years ago, we had a significant trend that people were building their internet presence on the social media platforms. But since some time, the trend is somehow reverting, or people building now the web presence not only on the social media platform, but as well, again, on the hosting platforms. And there might be a couple of reasons for this. First of all, I do believe that the simplicity to build web presence in hosting platforms has really, really improved. Secondly, they're very secure, they're absolutely reliable, and they're pretty fast. So let's go back to the future. This is a sneak preview of how web hosting platform today is built. On the bottom line, you see several thousand servers of resource pools in a geo-redundant mode. We operate usually at least 2 data centers in a country. On these resource pools, we have LXC containers. And inside the LXC container, we operate in C-group separated web spaces. And inside these web spaces, customers have their content either built by website builders, built by static site generators, or built by WordPress. Who's using WordPress? Anyone here who using WordPress? Should be a few of them, because 1/3 of our web pages, 1/3 of our web pages is built by WordPress. And the challenge here is really to make it really fast. So what we have is a layer on top. Again, having significant, strong resource pools, using LXC containers as well, but this resource pool is using our own application and software. It's for DDoS protection, very significant. There are more than 1 to 2 million requests per second, and I'm not saying that all of them are friendly requests. So we need a very, very strong DDoS protection layer, as well as CDN, SSL, web application firewall. For this, it all resides all in the top layer. And that's a good reason for having all the effort. At the end of the day, customers want to have secure, reliable, and very fast platforms. So latency time should be very, very low. And there are a couple of tools out there in the market you can prove that you're reliable and that you're pretty fast. One of them is Web Host Checker, tells you what the response time is. And here for WordPress, you can see that you can achieve, with the right configuration on the right platform, a really, really significant good response time. So how does it all work? And where's Intel inside? The technology Jeff just mentioned, especially the Cascade Lake together with Obtain DC persistent memory, is really the breaking technology on the CDN caching layer and the DDoS protection layer. I would even go that far that the performance we can achieve today with a load in the internet, friendly fire and not friendly fire, is only able to be served by such a combination of technology. And it's not only that you have to leverage from the technology, that only install the technology, you have to have a strong partner with you that allows you to optimize the technology, your software stack, to run on this technology. So that's exactly where we benefit from this partnership with Intel and all the technology Jeff was able to provide with his teams. But it's only possible in this strong partnership with Intel, using, especially for the caching layer, a really cool combination of Intel technology.
All right, thanks, Reiner. That was great to hear. Very excited about seeing that coming out, and thank you for the great partnership.
A pleasure.
I look forward to more in the future. Thanks. So as you can see, 1&1 is a great partner for us and one that's driving a lot of infrastructure innovation. We have a lot of other great partners across the space, and we've listened to the voices of the cloud service providers globally over the last decade. And there's really some common themes that we've heard over the last 10 to 15 years as we've matured and grown alongside those cloud service providers. One, hypervisor and virtual machine density with performance is incredibly important. I think as you saw earlier with some of the key product innovations we have, we're innovating and we're optimizing our products specifically to be able to meet those needs. The other is that total cost of ownership at the rack level is extremely important. So we've seen an evolution from looking at things at the processor level to the server level, and now out to even the rack or the data center level. That's the important metric of interest, is total cost of ownership and performance at the rack or even the data center level. Third, an even greater level of sophistication around telemetry, cloud management is important in order to make sure that you can load balance, you can scale, you can optimize the instance matching to the specific customer's workload. So we're continuing to work on new features, creating new fundamental architectural features that allow you to more easily manage your resources, orchestrate them, and monitor them via telemetry. Also, power is extremely important. Whether that's because of the cost of power, that's because of limitations with rack density, because of the locations where the servers are located, whether it's thermal concerns. So we continue to optimize around power. And that's not just a comment around the CPU itself, that's optimizing for power at the rack level using solutions like our data center manager and other more advanced and automated telemetry techniques. And then lastly, it's important that we develop industry standard APIs. So the work that we do within open communities is extremely important to ensure that it's easy to move workloads from cloud to cloud. It's easy for end users to pick the right instance and to not be locked into specific services that hinder their growth. So it's important for the entire industry that it's easy for people to consume the cloud so they can consume more and more of it. And so as we look at some of the key things that we need to deliver in order to help that growth, and looking at some of the themes that I mentioned before, I'd like to talk a little bit about our new high-density cloud-optimized platform. Well, we talked about this 2 weeks ago at OCP Summit in San Jose. And what we've done here, we looked at some of those needs, the need for extremely dense platforms in the infrastructure as a service space, bare metal as a service, in the hosting space, and the fact that those need to be delivered efficiently in a cost-effective manner. And so we've worked with key partners to develop a reference architecture for a 4-socket platform that delivers industry-leading core count. It delivers up to 112 cores within a single server. It delivers up to 12 terabytes of memory if you use our Intel Optane DC persistent memory. And it offers up to 192 PCIe lanes. So it offers extraordinary scalability, extraordinary options. And you might think, 4 sockets expensive. I don't see the systems that I want out there. That's why it was important that we actually develop this with cost efficiency in mind, with VM density in mind, to ensure that it met the requirements for high density and cloud cost optimization. So by deploying this type of a server solution, we see TCO improvements greater than 5%. We see performance gains, flexibility, so a lot of key improvements. We actually developed this hand in hand with a number of global cloud service providers as we built the requirements and then worked with the ecosystem to deliver the solution. So what would you use this high-density cloud-optimized platform for? We see usages here from a HPC standpoint, bare metal, any kind of infrastructure as a service offering that benefits from thread or core count density, database applications, web front end, or more value type of usages. We see value here in the storage space as you're able to scale out. Any kind of container-based service, container as a service, these are all usages that would benefit from this type of high-density, cloud-optimized platform. And so we have a side-by-side here so you can see where some of those TCO gains actually come from. So we have a more typical 1U 2-socket rack and then a 2U 4-socket, the new high-density cloud-optimized solution built out into a rack as well. And by delivering this, we're able to deliver greater VM density. There's efficiencies in power. We have efficiencies in licensing costs, as well as just simplicity in data center management. Now, you might ask yourself, do I need that level of compute? Do I need that much memory? Do I need that much I/O? And the important thing to realize here is that we're building a portfolio that scales up and down to meet your needs, to give the flexibility no matter what your needs are from a compute standpoint, from a storage standpoint, from a network standpoint. And we've worked across the ecosystem to enable this platform. So I mentioned that we announced this at the OCP Summit 2 weeks ago. And we have a number of partners who have worked with this on us. So you'll see a number of the names here that are out there in the exhibition hall today. We also demonstrated a demo with Inspur 2 weeks ago. So plenty of options out there to choose from. If you have questions, I invite you to come by the Intel booth or talk to some of our partners about how this platform will be utilized. Okay, so getting back to wrap it up to the actual value that end users see by using these technologies. So I want to highlight some recent results that were reported by a third party that show the performance per cost comparison of instances at a major cloud service provider that are based on Intel and those based on AMD. So we measured a variety of workloads to assess the performance and match it up against the cost that the end user would see. And it was noted that the performance per cost was anywhere from 25% to 4.1x higher with the Intel instances than with the AMD instances. So this highlights a couple of things. One, the performance is extraordinarily important, and not just the performance, but it's the performance for the workload that the end user actually cares about. And so with some of those optimizations I talked about earlier around AI, the work that we're doing with frameworks like TensorFlow, with Caffe, with MXNet, and work that we do in the optimization space around other workloads as well, right? It's important to actually go look at the real performance results on real workloads, real benchmarks, and then do a fair comparison of the performance and the cost to the end user of the offering. So we think that from an Intel perspective, we're able to offer the best performance per cost across a wide variety of workloads that end users actually care about. So it's important to focus on what that real business result is, what the real end user is going to see. So I'll close today with showing you again one reason why I really love working for Intel, and that's just the broad portfolio that we have, the full commitment we have to delivering the full solution stack, the fact that we're able to innovate across the entire platform, the deep partnerships we have with cloud service providers, and that deep history we have of decades of experience of innovating, and the fact that we'll continue to do so for decades into the future across compute, across storage, across networking. So thanks for all of your time. I would invite you to celebrate this amazing technology this week with us. Come by our booth. We have a number of demos running out there. You can see our Intel Optane DC persistent memory. You can see some of the work that we're doing around the FPGA space. So come by, talk to us. We'd love to figure out how we can partner more closely together, help you deliver some of those amazing business results to your end users using the amazing innovation that we've been delivering in the cloud. Thank you.